Okay, so we're going to do some extra practice for section 2.3, proportions. Starting with the two similar triangles here. And again, remember that similar means they have the same shape. Their angles are equal. They just have different sizes. We're going to solve for x using proportions. So this is x here. It's the missing side here on the smaller triangle. I'm going to label these two triangles right off the bat as large and small, so we can set up our proportion as large over small. Which two sides do we know? We know the 30 and the 20. So we'll start with those. 30 over 20 is equal to, and then again on the large, 18 over x. And once you have your proportion set up, then you're going to make an equation using the cross products. So 30 times x, 30x, equals 20 times 18. And simplify, 30x equals 360, 20 times 18. Isolate that x by dividing by 30. We get x equals 36 divided by 3 is 12. And on number 2, we have similar triangles again. This is a little bit more difficult to see, but these triangles really are the same shape. The smaller one over here to the right is just a mirror image of the larger one, but they are the same shape. When you have mirror image triangles like this, you can still label them as large and small. You just have to be careful which sides correspond, because the 24 is not corresponding to the 10. It's not in the same position. The 24 is actually corresponding to the y. The 12 is corresponding to the 10 because they're both in the same position. And the x corresponds to the 5. So what are we solving for here? Solve for x and y using proportions. Okay, so we're going to have to do this twice. All right, we're still going to do large over small. So which two sides do we know? Okay, the 24 corresponds to the y. That's not going to help us. The 12 and the 10 are the two sides that we know, so we're going to use those. We're going to use 12 over 10 corresponds to, let's solve for x first. Let's solve for x, and the 5 corresponds to the x. So we're going to use x over 5. And then we'll use the cross products. So 10 times x equals 12 times 5. When we simplify that, that's 10x equals 60. We divide by 10 to isolate that x, and we get x equals 6. So we know that x equals 6. Now to solve for y, we can use this same proportion, 12 over 10. That's large over small. This time when we're solving for y, we're looking for the side that corresponds to it, and then that would be the 12. Well, I'm wrong. That's the 24. So 24 over y. So just to clarify, the 12 and the 10 correspond, and that's where this comes from. The 24 and the y correspond, so that's where this is coming from. And the cross products again will tell us that 12y equals 10 times 24. Simplify. 12y equals 240. And divide by 12 to isolate that y. We get y equals 20. Okay, set up a proportion of the following situation. Do not solve the proportion. Jim can paint a room in 3 hours. How long will it take Jim to paint 5 rooms? So again, with word problems like this, it's all about what two things are you comparing. It looks like we're comparing the number of rooms to how many hours it takes. So we'll start with a proportion that outlines rooms and hours. Okay. And remember, these come from the first part of the story. Jim can paint a room in 3 hours. That's one room for 3 hours. How long will it take Jim to paint 5 rooms? So where's the 5 going to go? The 5 goes on rooms, and we're looking for hours. The question tells us we don't have to solve, but we're going to circle which of the following proportions are the same as the proportion the proportion of this problem. Okay, so this is the deal. There are 4 correct ways to write the proportion. I've been showing you what I think is the easiest way, but this is not the only way. And in the lesson I mentioned you could also put hours over rooms. You could flip these as long as you do the same thing on both sides. But it also turns out that you could put rooms over here and hours over here, and they could be flipped. There are 4 correct ways to write this. I think this is the easiest way, but sometimes you got to find identical proportions. The easiest way to do that is to make your equation using the cross products, because all the correct proportions make the same equation. So I'm going to make an equation out of this using the cross products. I have 1 times x, or 1x, equals 5 times 3. And then I'm going to compare that to these. Any of these proportions down here that make this same equation are going to be correct proportions. So the x needs to be times the 1, and the 5 needs to be times the 3. And if you look at this first one, that's exactly what you have. This is identical to ours, so obviously this one is correct. This one does not have x times 1, it has x times 3. So this one is not correct. This one has x times 1, 5 times 3, so this one is correct. This one also has x times 1, actually this one's identical to this one, isn't it? So obviously it's correct. This one has 3 times x, 5 times 1, this one is not correct. This one, x times 1, 5 times 3, so this one's also correct. So that's how you find all the identical proportions. You first write your proportion, the easy way that I showed you. You make an equation, and then you compare that equation to any other proportions, and they should make the same equation if they are a correct proportion. All right, number 4. Set up and solve the following proportion. A car can travel 500 miles on 25 gallons of gas. How many miles can the car travel on 10 gallons of gas? All right, so we're going to start with our fraction bars and identifying units. What are we comparing? A car can travel 500 miles. So we're comparing miles to gallons. So we're going to label this miles and gallons. A car can travel 500 miles on 25 gallons. That's a G. Looks like a Y. How many miles can the car travel on 10 gallons? So the 10 goes down here with gallons. And what we're looking for was up here in miles. All right, the cross products tell us that 25 times x equals 500 times 10. We simplify. We get 25x equals 5,000. We divide by 25 to isolate that x. We get x equals 200. Does that make sense? A car can travel 500 miles on 25 gallons, so 200 miles on 10 gallons. Yes, it does. That makes sense. All right, number 5. Set up and solve the following proportion. If 5 pounds of candy costs $6, how much does 7 pounds of candy cost? Okay, what are we comparing here? We're comparing pounds of candy to cost, or dollars. So we're going to set up our proportion, pounds to dollars. Pounds to dollars. And these numbers, 5 pounds cost $6. So 5 pounds, $6. And these numbers, how much does 7 pounds? So 7 is pounds, and this is what we're looking for. All right, the cross products tell us that 5 times x equals 6 times 7, or 42. We divide by 5 to isolate that x. All right, now, I could make this into a fraction. I know this becomes 8 and 2/5, but that doesn't make sense. We're looking for dollars. So we usually express dollars in decimals. So I'm going to divide this 5 into 42, and I'm going to make it a decimal, because this is how we express dollars and cents. So that would be 8 And this is 8.4, and there's no leftovers, or $8.40. All right, does that make sense? If 5 pounds of candy costs $6, how much does 7 pounds cost? $8.40. That's very good.